Hello, so these are the test 2 open-ended questions that we'll be working through here. So we'll be working out the first one where there's the 4 charges, A, B, C, and D respectively. And we'll have +1 COUL over here, and then a +1 COUL over here. So basically what you need to do is to consider the charge at point A and D is going to be Q, and then the length of each side of the square is going to be L. And so the force on B due to A is going to be represented like this. So we have KQ for A multiplied by KB over the length squared. Now the force on B due to C is going to be KQCQB over the length square root of 2 squared. And then the net force on B due to A and D as well will be square root of 2 times KQA QB over L squared. Now finally, we'll need to find, the question's asking us to find the charge on A so that the force on D is 0. And so what we'll need to do is have the force of B equal to the square root of 2 times KQA QB, and then plus KQC QB, and then these will be over, so L squared 2, and I'm just getting these from up here, so I'm just plugging them back down up here to find the net force. So then this will also be L squared right here. So that one's that one, this one is just right there, and then this will be a net force of 0. And then what we'll need to do is to plug in the values. So since they both have a charge of 1, we'll go ahead and plug that in. And so we'll have the square root of 2 times KQ times 1 over L squared times K times 1 over L squared, or square root of L times the square root of 2 times squared, and then equals 0 again, and then we'll have the square root of 2q plus the 1/2 equals 0, and then q equals negative. So what this is right here is to condense this down further, and so the overall charge will be 1 over, and we isolate q here, and we'll have 1 over 2 times the square root of 2. And then when we solve for that, Q will be equal to negative 0.35 coulombs. And this will be the required charge for point A in order for the force on D to be 0. So my answer is negative 0.35.